Hello everybody, so this is a presentation about cloud gaming for THREE.js. So let me start. What are we gonna talk about? We're gonna talk about a possible solution for cloud gaming. This applies to any WebGL game. This is quite important. I do THREE.js, but you can do that to whatever Canva you got. As soon as your stuff is rendered to Canva, you can apply it. It's a quite cheap idea that I implemented there. It's quite naive, but it has been implemented in like 24 hours. So that's pretty cool. It's naive but works quite well. So first, the demo. That's a video I took about it. Let's look at it together. Pretty meta.
Cloud gaming for THREE.js. And did a little experiment about cloud gaming, so this is just a presentation of the result. Here you got a mobile phone which doesn't support WebGL. On here you got a computer, usual desktop. We're gonna load what we call the remote renderer. So on this browser we're gonna render our WebGL scene. So here you can move the guy, blah, 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 blah. You move the guy. There's here a server receiving the screenshot for your stuff. You receive all the screenshot, and they are sent to this mobile device. What is the interesting here is this mobile device do not support WebGL. Still, as you can see, we can have the WebGL render on the mobile phone. It's quite responsive, surprisingly responsive. The code was done in less than 24 hours, so it seems almost viable, guys. Well, it was fun. See ya.
Okay, so this was a demonstration of the concept. I can show that to you right now with a single screen. So what you got here is what I call the renderer. So you got my WebGL scene here. This one is a renderer. This is an iframe which acts as a renderer. So this is actual WebGL here. You can move you are supposed to be able to move the guy. You are able to move the guy by the keyboard here. I press the keyboard in the renderer. The guy is moving. What do you see on the left? You see what you are supposed to see on your controller. This is an iframe. This iframe is supposed to be displayed on your mobile device. So we put some virtual joystick in order to accommodate the fact that it is a touch screen and you got a mouse or no keyboard. So you go to the left, you go to the right. In fact, what you see here is not at all WebGL. The WebGL is rendered on the left, and what you have on the right is just what you see on your mobile phone. It appears to be like WebGL, but in fact this is only image which are rendered on the renderer. The main advantage of this is you don't need a WebGL phone to render a WebGL scene on mobile device. It's quite cool. So this is a concept. Now let's see how we cut that. Let's come back on the slides. So what is cloud gaming? There is a Wikipedia definition, but when you read it you find out that this concept is too new. There is no widely accepted definition for it, which is okay, but usually it's implied render on server. That's like command ground. Cloud gaming means that you render your scene or your game on a server far from the actual players. So the definition I try to corner is trying to run a game. So what is cloud gaming? This is trying to run a game written for device A on a device B, typically dumber than A. So in our case, you are doing a WebGL game. This WebGL game has been written for desktop, and you are trying to display that on non-WebGL mobile. This is what it is for us. This is our use case. Let's clear that a bit. We have a WebGL game in a browser on a player device, play this game through a non-WebGL mobile device, typically your phone. Okay, so we need to have the game playable on the non-WebGL phone. This is our goal. So as I just said, and well, no, we got the target, but what's next? We have a good definition of the problem. Early study of the problem for the early prototype. First, the rendering. We got to render our game in server. We have a WebGL game, so the renderer will be a browser. That seems all natural, right? So we render our game in a web browser on the server. Web browser on the server, new concept. So what about the architecture? There is what we call the renderer. That means the part which is supposed to render the game. So in our case, that's a web browser running the game. There is a controller, which is basically your phone, your mobile phone. And this device, the controller, this is what is used by the player in order to play the game. So typically a small device, touch screen, these kind of things. And we got a server. A server here is mean a network server. This server is just there in order to ensure communication between the two others. So the communication between the renderer and the controller. We got the architecture. Now, what about the networking? It happened to be quite simple. First, all is done through WebSocket, which is completely admitted as a technology. You can use that everywhere where you can use WebGL or anything. You put Socket.io on your, quite cool. There is a new protocol called WebRTC, but the WebRTC is quite young, a lot less available than WebSocket, and especially on mobile phone. So for now, we did a quite naive implementation through WebSocket. Early study, the software. So what are we going to use for the software? Well, the server going to be Node.js. This is a very small server. Let me show that to you if I can find it in a bit. Okay, that's probably too hard to find. But believe me, that's like not even 20 lines. That's really small. And this is just an echo server doing the communication between the renderer and the controller. There is a little library on the renderer, another on the controller. All that is only very common technologies. There is nothing hype, no new API which just popped out. This is very old technology. The newest is probably 3 years old. So the implementation is quite simple. The code is simple, the code is short, everything is well-established technology, implementation is easy. So all that look good, but what would it be in action? So let's have a theory of operation, something like what's going to happen in the wild. So we got, first things, a renderer or browser running the game. So you have your WebGL game that you have written, you put somewhere a web browser, and you make it run your game. This rendering browser will take regular snapshot of your WebGL game through an API called Canva to data URL. Quite simple stuff. Once you got the snapshot, you just send them to the player device through the echo server. So that's it. That's already simple. You got a renderer inside a browser, you run your game there, you take periodical snapshot, you send that to the server echoes that to the player device, which can be a mobile phone, a tablet, whatever. After that, the player. So the player can see the WebGL rendering on any device. The player uses a touch screen as input, so as we have seen in these examples. For example, the blue things is like me touching my screen. This is working well on mobile, as you have seen in the YouTube demonstration. So the player used the touch screen as input. The input are sent to the server, or the server sends them back to the renderer. That's pretty nice. So the player sees the WebGL rendering on a non-WebGL device, already quite cool. And after that, he can interact with it with his touch screen. So the real result is what? The browser receives the input from the player, and the player can see what is displayed in the browser. We got the whole loop, guys. This is it. This is no more complex than this. This is the beauty of it. Oh, by the way, the whole library is 300 lines, server included. So, seriously simple. So, we got actual gaming, cloud gaming with it. This is a sample implementation. It has been done in 24 hours. Performance, let's say, I left as an exercise to the reader. And but it's working quite well. I mean, I do like 20 FPS over Wi-Fi. 20 FPS is pretty cool, I mean, over Wi-Fi. So, now that we have seen the concept, let's look at the code a little bit. The implementation that we made. First, the status of it. It is working and available. That means that these 300 lines, they are published. You can find them on GitHub here. You got them on GitHub. That's a bunch of 3x extension for THREE.js, and it's all under MIT license. So really easy to reuse all that. If you want, you can even implement your own. I mean, it's not like it's hard. So what do we got? We got a mini game using THREE.js running the renderer. So what is this mini game? This is this one, guys. We got like a Minecraft characters. The Minecraft character can move through the keyboard. Okay, the minigame is not that great, but that was not the purpose, right? No matter how complex is your WebGL game, the cloud rendering doesn't care, right? Because you just take pictures. No matter how complex is the pictures, doesn't change much. Okay, so let's kill this. We got a minigame which ran on the rendering browser. We got a controller for this game which ran on the player device, so the mobile phone of the guy. And we got a server to communicate between both. Simple, not JS, socket.io stuff, very simple. The whole thing, as I said, is definitely simple. As you can see here, that's 300 lines. No more for cloud gaming, the very hype thing that they talk about all the time. The rendering of the minigame. So how I made the minigame. That's just a bunch of 3x extension. So you go here, you got that's the 3x site, and you got all the extension here. You can pick, you can install them. A lot of cool things in there. Okay, so for example, this one is a mountain that you see in the back. When in my minigames there is a bunch of mountain, this is those mountain. So I took a bunch of 3x extension and put them together. First 3x extension is the Minecraft characters that you play around. After that there is a mountain arena all around. Let's come back on the demo to see what I can do. So there's a Minecraft character in the middle, the stuff that you move here. There's a grass ground as well. So you got the mountain all around. You can see the sky maybe. There is a big sky map. And you see, you take all those 4 3x extensions, you put them together. That's like maybe 20 minutes of work to obtain this. So that's a very simple minigame. After that, for the controller, what have we done on the controller? We need obviously to render. Yeah, doesn't work. Come on back to daddy. Okay, so we use a virtual joystick. So this blue thing here, that's a virtual joystick that I did several years back in order to, I'm gonna say, well, to have a joystick on a touch device, right? It's pretty cool. You export left, right, up, down. Very easy to integrate and very easy to use. Okay, so we put that. There is a post on Learning THREE.js blog. Provide up, left, right. That's it. The core. So for the implementation, the core is what we call 3x Cloud Gaming. So this is our 3x extension. There is 3x Cloud Renderer and 3x Cloud Controller on the server itself. All that is the networking part. That means that the renderer gonna connect the server gonna connect the renderer, and so on. Screen updaters, what it is about. That means that the renderer will take a picture and send that to the server will echo that to the device player. That's it. All that, 100 lines. Oh yeah, and there's some funny stuff with resolution. When you take your mobile like that, or like that, or like that, I handle those cases. The virtual joystick. So the virtual joystick is to handle the joystick itself. Well, that's it, guys. When you look at it, that's pretty neat. That means that you can play a WebGL game on whatever mobile device that can display an image, if you got the network for it. I'll leave you on that. See ya, guys. I hope you have fun. I like the concept. Bye.